luminaires, but it's still we put the different things, we put reflectors together, then we changed to electric light and we use the same technology. Then LED came along and everyone went, oh, everything's going to change. But essentially, optic, perhaps a piece of glass, and we direct the light where we want it to go. No different. The only
Aqui entrar.
with good eyesight. So typically a 22-year-old woman has the best eyesight out of anyone. We give them these colour charts here. They're labelled 1 to 14. First off, we give them 1 to 8. Okay? And we ask them to rate how true colours are under different light sources. It's a human thing. These people are expert at doing it. Okay? If they think the colour is very true, you get a very high mark. If they think the colour is very poor, you get a very low mark. Then we come along, because we're now international as a lighting industry, and say, yeah, actually skin tone's quite important. So colours 9 to 14 start to represent extreme colours and skin tones. You can get different colour rendering scores based on whether you use colours 1 to 8 or colours 1 to 14. Cheap LEDs will be measured under 1 to 8 because you can fool the system. Expensive LEDs will be measured under colours 1 to 14 because it's much more difficult to fool the system. So you want to ask the question, have I got a good LED? Just ask the supplier, which colour rendering score you use, 1 to 14, R14, or 1 to 8, R8. And then they'll give you some wonderful arguments about how it doesn't really apply. But it does. The eye recognises the colour, the light, the quality of the light determines how well you can recognise the colour. And it's all down to a thing called red, green, blue. What's in your eye? So I have 3 curves here. They're the response curves for the eye to red, green, and blue. If you're colourblind to the eye, so the peak response of the eye in blue, around 450 nanometers. Okay, too technical, but if you put lots of that light in, you will fool the eye to thinking that blue looks really blue. But lots of peak in red and green, you can fool the eye into thinking that actually white is very white. So we can, with LEDs, because generally they use red, green, and blue light mix, we can start to fool this system, and that's the problem you have with colour rendering and LEDs. You never had the same problem with any other light source, because you couldn't fool it. But now with LEDs you can. So actually the one way to test with colour rendering, take your LED product, light something you know and love. So if you're going to light a store, light some of the product with it, and take the product outside on a nice day, see if it looks the same. And you know you've got good colour rendering if you can't really tell the difference. If it changes from blue to green, you know you've got a poor quality LED, go and buy something else. It's the very yellow road lantern. Okay? Very common in the UK and across France. Then we have high pressure sodium, which replaced it, much more efficient. You can see the reds and the yellows start to come more alive, the blues are pretty diminished. Then we have white son, which is used in retail. Then you start to see some of the greens come to life and some of the yellows. That's why we use white son over salads and things, to make it look a little bit more healthy. Then we have metal halide. This is quite an old metal halide. You get reasonable colour rendition. LED, I mean, it depends on who you buy it. You can get great colour rendition, really true colours, really atrocious colours. Tends to be the cheaper it is, the poorer the colour. I didn't notice it here. If you travel to Europe, go in a lift. As you travel between floors, have a look at the light fittings in the lift. They're normally twinkly tungsten halogens like this, but in Europe they've been replaced with cheap LEDs. One thing, you won't be able to see your feet because there's not enough light. Secondly, the colour rendering will be very bad. You'll look very stiff, drawn out, your clothes will look an awful colour. It's because they wanted cheap LEDs. Yeah? Why would I pay 38 euro cents for one of these and £20 for an LED? I know you say it lasts a long time, but it's not worth it. So they'll pay €1.50, something like that, for an LED replacement. Of course, you don't get the quality. When you're going to market clothes, fruit and vegetable, colour is vitally important. So then use good quality light sources. Glare, subjective thing. Light source looks really bright, especially if the background immediately around it is very dark. So if you've got very directional light sources, then they're always more glaring. Generally, LEDs are very directional light sources. They're much more like this than they are a fluorescent lamp. So if you don't light the surfaces behind them, you're going to get glare. It's going to be uncomfortable. If you want to sit in here all day and look at me, it's going to be very tiring to your eyes. And that's because of glare.
So, if you can get light onto the walls, if you can get light behind the luminaire, if you can get good balance between the face and the background, then glare reduces. You get it with all light sources. LED just tends to be more directional, therefore you should think about it. Anyone heard that they last 35,000 hours? Yeah? So notice it's moved from 50,000 to 35,000. In fact, in some light sources now, you get 20,000. Yeah, it's not a surprise, really, is it? So I'm going to go from a business model where my light source lasts 1,000 hours, if I'm lucky, to something that lasts 50 times as long and I'm still going to stay in business. No, no. What you want as a lamp manufacturer is frequent replacement lamps. So 50,000 hours doesn't make a lot of sense. 20,000 hours makes some sense. So you can see the lamp manufacturers are pushing hard to change life. Now, actually, that's not a bad thing, because in something like retail, to last more than 20,000 hours, the chances are the lamp has been taken out and thrown in the bin by then anyway, because the shop's been refurbished. The average life of a luminaire in a shop across Europe, 18 months. Even if you run it 24 hours a day, you're going to struggle to get that sort of, you're going to be about 7,000 hours perhaps, 7,000 to 8,000 hours. So it doesn't make sense to make something 50,000 hours. Now, if you go into street lighting, 50,000 hours could be 25 years, then that makes a lot of sense. If your luminaire lasts in the environment for 25 years, and we, believe it or not, we do design them to last that long, then 50,000 hours makes a lot of sense. How's it measured? Well, it's a bit of a difficult one, because if I measure it carefully, I can give you 100,000 hours, 200,000 hours, whatever. I have to stop somewhere. So in most luminaires, we measure them at 25-degree ambient, indoors temperature. Take the luminaire, we run it up to its running temperature, and then we measure how many thousand hours it lasts. And there are LEDs in the world that have run for about 9,000 hours, perhaps 12,000 at most. We statistically calculate whether they will fail and how far in the future they will fail. So there is not an LED running, a modern LED running in a lantern that's done 50,000 hours. There are samples around the world, and depending on how you measure them, some look like they'll last less than 50,000 hours, some look like they'll last considerably more than 50,000 hours. Some fail very quickly, some have experienced no failure whatsoever. The difficulty for you is they very rarely fail. It's parts per million failure rate. So the chance of an LED actually going out, if it's a good quality LED, is pretty low. How do you tell? Well, through life, they stop giving out so much light. So on day one, they give out 100%. At 50,000 hours, they'll be giving 70% of the initial light. You could run them for 200,000 hours, and they probably give out 30% of the light. The point is, at what point do you notice that they're not giving out so much light? So it's very, very difficult. They're not like traditional light sources. So we can say they'll last 100,000 hours or 150,000 hours, but it's really a best guess. There is no guarantee. If someone offers you a warranty, read the detail carefully. What you want is a luminaire or a lamp manufacturer who, when you have problems, looks at it seriously and says, okay, I understand what's happened, there's a solution, or I'll do my bit to put it right. But they're just like any other light source. They are going to fail at some point. Now, if you buy them here and install them in rows, what's the average nighttime temperature here? Probably 4 or 5 degrees. Yeah? So test them at 25 degrees and install them at 4 or 5 degrees. LEDs love to be cool. So they will last much longer here. If I sell them into the Middle East, average nighttime temperature 40 degrees. Much higher, so either I've got to get the heat out of the LED to get the light, or they will last a much shorter time. So again, you have to ask the question, if I'm buying your LEDs and I'm installing them at about 5 or 10 degrees, what's the predicted life? And most reputable manufacturers can give you a curve that will allow you to work out difference and see how much longer they will last. LEDs also love to be dimmed. So this little thing here is running on mains, and you've got a sinusoidal waveform through it, and you can't tell that actually the current is going opposite, because it's a piece of metal, very, very hot. and it just gives out light. LEDs don't run quite the same way. We correct the sine wave, and we switch them on and off very, very quickly. Good quality power supplies, 30,000 times a second. Poor quality power supplies, well, they're the ones you can walk down the DIY aisle of UI, you can see them flashing, yeah, because they're switched about 50 times a second, or 100 times a second. If we want to dim them, we just cut that pulse shorter and shorter and shorter. So it's giving out less light, or light for less of the time. They love to be switched. So if you now put them on things like passive infrared switches in toilets, they love it. You won't harm the life at all. In fact, you probably won't make it better by about 10%. If you switch these, same frequency, eventually they'll go pop. If you do compact fluorescent, a 9,000 hour lamp will last about 1,000 hours. Compact fluorescent hate it. So if you're going to do WCs, put LEDs in. Put them on a passive infrared, saves the power, and they'll also switch it. In street lighting terms, we can dim them. Across Europe now, you can dim roads after a certain time of night when the traffic density's dropped or when there's not less pedestrian traffic. You can dim it out to about 50%. Still get away with it legally because there's less risk. We save about 25% power, but we also see a 10 to 15% rise in lifetime of the LEDs. So when I say 50,000 hours, it might be 60 or 70,000 hours just by dimming them. So they have some advantages. Of electricity. So the English word changes from efficiency to efficacy. So efficacy, you will be told, I have on my desk at home a 258 lumen per watt LED. And as a lighting man, I get quite excited by that. It's really quite scary, isn't it? 258 lumens per watt. There is no other light source in the world that efficient, apart from the sun. But I can't get that in a real lantern, because I have to put it inside the system. I have to control it, I have to put gear on it, I have to put optics on it, I have to keep it cool. By the time I do that, I lose a lot of efficiency. So when you're asking about efficiency of luminaire, ask how much power goes into my luminaire, how much light do I get out of my luminaire, not the LED, because they're different things. So all the standards are now starting to move towards quoting system efficiency or system efficacy. Across Europe now, to talk about lumens per watt of the LED or the light source just doesn't happen. We talk about luminaires. So things like watts per meter square, electricians, watts per meter square, yeah, rubbish. Complete waste of time, except, of course, you need to know your distribution board and how big the fuses need to be. Lumens per watt, lighting people get really upset about because it doesn't mean anything. Luminaire lumens per watt sort of means something, and then the politicians love this one at the bottom, CO2. Yeah. How much is a kilogram of CO2? Well, it's a balloon that's about 2 meters diameter. Yeah. Okay, what's that mean? Actually, the aim is to reduce the amount of power you use. Lots of light sources are good at that. If you're in office lighting, T5 fluorescent or T16 fluorescent, the thin fluorescent lamps, they're still more efficient than LED. Just. But we're seeing a change there now. I'll give you an example, or a couple of fun examples, I think. This is a lantern I worked on 25 years ago. Okay, it gives out just golden yellow light. You stand under it, you look warm, healthy, you can't tell any colours. It gives a peak, at the peak sensitivity of the eye to overall white light. So it's very, very efficient. We defined efficiency by this, what you could see. Doesn't matter how much money you spend on your car, it's going to look rubbish under this light source. But it's safe to drive under. And it's great if you're an astronomer, you want to see the stars, you put a filter over that just takes out that one peak of light and you can see everything else. So it's a wonderful light source, okay? Then we come along and we develop fluorescent. And fluorescent has this curve at the bottom here. You start to see peaks in reds and yellows and greens and blue, so that your expensive Boss jacket, okay, your expensive John Lewis jacket, looks a good colour. When you talk to your colleagues, they look a good colour. We come along with LEDs and we try and match the curve. We haven't tried to make it any better, but there are companies, Cree would be a good example, who are trying to make the quality of LED light much better for the same price. Okay, so we are seeing some improvements. have the best carbon fibre brakes that stop on a sixpence. But if the tyres don't hold you around the corner, or actually the driver's no good and can't steer because he's drunk, it's no good, is it? You've got to look at the overall system. So that's where we're moving to in lighting. Across Europe, to a certain extent the States, Middle East, Australia, some of Asia, we're seeing people stop talking about individual luminaires and installed efficiency. How much power you use per metre squared per year, including light sources in luminaires and your controls and your emergency lighting and your emergency lighting charging power and any of the systems that monitor your lighting. Why? Well, it started with this. This is now 2 years out of date, so you can read that as 268 lumens per watt. You can't buy that, well you can, but you normally buy it in one of these. So we put primary optics, we put a lens over the LED, then we put secondary optics, which is the aluminium to reflect the light and control the glare. Then we put it inside a housing, we put some glass on it to keep it clean and to keep the moisture and the dust out. And when you've bought it, you might be 50% of the initial efficiency. And then you put it on lighting controls, you might get another result. So you can buy probably in office lighting 80 to 90 luminaire lumens per circuit watt. In road lighting you can probably get up to about 105, okay, which is not bad. So this is what I was talking about. If you run it in a colder ambient, you get better life. Then you can look at dimming. If you dim it, you can get longer life. Suddenly you need a lighting designer. I've trained as a mechanical engineer. Now I'm retraining, qualifying, even after 25 years, I'm still learning in lighting. But you need some qualification because across Europe, you will have to be a qualified professional lighting designer to specify lighting. Because the story is getting so complex, you need to understand. It's like, you wouldn't expect me to size cables for electrical installation, because I'm a mechanical guy. I can tell you when they'll break, I can't tell you how much current they'll draw. So we're now seeing also professional lighting designers appear, and part of that is because also you've been sat under tungsten halogen artificial light for the last, I don't know, 25, 30 minutes. And it's affecting your eyesight, it's affecting your brain, it's affecting your state of alertness. Whether I'm boring or not, the lighting is having an effect on you. Your bodies have developed for the last millennia for daylight, and we're bringing in light sources that have some risks. On where you're lighting, and what you do in terms of controlling the light source. Anyone heard of blue risk from LEDs? No? French did this wonderful report, and they picked on some, so they paid some researchers to put an LED light source here, and they paid some, what do you call them, students to sit in front of them and look at them, and they measured the retinal damage. So at the back of the eye, they looked what damage was done, and they said, if you sit in front of an LED at about 1 meter distance and stare at it for 4 hours, it damages your eye. Yeah. Remember tungsten halogen? If you put your hand on it, it hurts after about 20 seconds. Remember that flame, that oil thing? Put your finger in, that hurts. Fluorescent uses UV. If you sit very close to a fluorescent lamp, it damages the eye. God forbid, metal halide. I run occasionally sports lighting installations. 2 kilowatt metal halide lamps, you run those with a glass out, you get a suntan in about 30 seconds. All light sources have problems. What you need to do is start looking at the install design, because we spend a lot of money putting that light source in there and taking all the risk out. That's why you buy a luminaire, otherwise you just buy a raw LED, it wouldn't matter. So reputable manufacturers are taking dangerous products, turning them into safe products. They're taking long lifetime products and applying them to the application. It doesn't always happen though. Anyone bought any of these? No? Well, there's a few smiles. You probably had the sales guy turn up and go, do you know what, you can take out your inch diameter tube and you can replace it with one of these. So take this one out, put that one in. And it gives you 300 lux, 3 meters from the center of the luminaire. Isn't that great? Saves you energy too. And you're immediately thinking, that's good. LED, got a long life, I've heard all about it, it's efficient, this is a really great story. No, it's not. Because you don't want 300 lux just on the centre line. A fluorescent lamp gives light out in all directions. It sits inside an optically designed luminaire that channels that light where it needs to go. So just replacing it. And then you get the poor electrician who has to come and rewire a luminaire, take out the starter, perhaps take out the ballast that was running the fluorescent, perhaps use wires that are rated at about 110 volts and run 220 volts through them. They might be rated at 16 or 18 amps, but you don't know what the inrush current is for one of these lamps. And then it goes wrong, and I've seen 60 of these burst into flames and cause about £70,000 worth of damage. And you get the phone call, Ian, your luminaires have burst in flames and it's your fault. Or, believe me, I had one or two dodgy moments when that phone call came through. So I went down to the site, and as I walked in at the back door, there were my fittings in the skip. And there were LED lamps still inside them. Now LED lamps need to be cooled. They need a specific voltage to run, and my luminaires are designed for fluorescent lamps. And I have to test, I spend a lot of money every year testing luminaires with the right light source in. So when you come and change my luminaire, I get really upset. So I turned around and said, sorry, the LED lamp doesn't comply to the lamp standards, which means it's not allowed to be used in my luminaire. You, not you particularly, but as an electrician, you rewired my luminaire, which means you have to go and retest it to make sure it's safe. So firstly, it's your fault. Secondly, it's his fault for designing a lamp that should work in the luminaire. Now, if you're buying these, beware. There are about 7 different types on the market. One of them, as you insert the lamp, you would never do this, would you? You always switch off the supply to the luminaire. Okay? But I know a lot of electricians who do not. So you put the lamp in one end, you twist it. This pair of cathodes become live, 220 volts. So be careful. Okay? There are other systems on the market that don't become live, but there are dangerous lamps out there. My colleague Michael from the Nordic region, there was research done up there, 20 different LED replacement lamps, and they found 14 of them to be life-threateningly dangerous because they were so badly made. Now, there are 2 or 3 manufacturers in the marketplace who make very good LED replacement lamps, who have thought about the problem, and they would probably work in my luminaires, but I still won't warranty my luminaires to take them. Because if you have to adapt the luminaire, and then you put one of these lovely fluorescent lamps back in it, that fluorescent lamp will go bang. So you have to label the luminaire and make sure it's only for one lamp. My advice would be steer clear. If you want an efficient LED light source, change the luminaire. You can probably do it quicker and more efficiently than taking the luminaire down, rewiring it, putting in an LED lamp. There are issues of life. I'm not sure on Icelandic law, but in Europe, if you do it, you have to measure now legally for the rated life. You have to measure the colour, the temperature, the voltage. You have to warranty the luminaire. You have to do you have to do electronic waste recognition. You have to register as a supplier. You have to collect the waste at the end of life. You have to do energy efficiency. You have to hang on cost. Last time I looked, these were 65 euros compared to, I can buy this for about €2.50. So lifetime just doesn't stack up. This is one of the problems with LED. This is the bad side of LED being applied, unless you're thinking and doing research. Sell our 8 millionth pot pack. I don't know where they've all gone. Somebody's got them somewhere, installed in their garage or something. You see the little slot in the side or the bottom of the single lamp? That's where the pins of the LED go, pins of the fluorescent lamp go in. You twist it 90 degrees, it makes electrical connection. If I do that with an LED replacement, when I put them in this way on the twin and I twist them. So you can imagine now the light on this one is pointing in a completely different direction to that it is in a twin. Now I designed my luminaires so they partly look aesthetic. It looks better to have the entrance for the lamp here on a single and there on a twin. If you did this in a corridor, would you have lamp light on your floor or light on your walls? Never thought about that one. When I said that to the guy from Philips, he went, yeah. okay, version 2 of our lamp's going to have rotatable end caps. So where the light comes out is quite important too. Held inside a quartz or a glass tube or a ceramic tube, and you pump electricity through them, and it's literally like a miniature sun. It vaporizes the materials, they give off electrons, we turn those electrons into light, photons, and you see the light. But you wouldn't want to stick your fingers inside, partly because there's a couple thousand volts going through, partly because those chemicals get pretty dangerous at that temperature. LEDs are almost the same, except we're using different chemicals and different reactions. But they give off all sorts of nasties, so we contain them. So there is a lens on an LED to keep all that nasty material in and keep the reaction going. And it's actually that lens that starts to die. That's why LEDs give out less light through life. If you use a cheap lens, then some of the nasty materials react with the silicon in the lens, and the lens starts to blacken, and you get less light. The cheaper the LED, the quicker it happens. Okay? You're not at any risk, don't worry. Now, that same material inside a luminaire can react with the materials I use in things like gaskets to seal the luminaire. So you have to not just take an LED and shove it in any old luminaire, you have to pick your LED very carefully, look at the chemicals used in it, look at the chemicals used in your luminaire, put the two together, work out whether it's going to be a problem, and design your luminaire. If you're taking retrofit LED lamps and putting them inside sealed luminaires, be very, very careful, because the chemical build-up and the heat build-up can make the luminaire explode. If you're putting it in open luminaires, I don't really have a problem. But there are some sealed luminaires you need to be very, very careful. You can get chemical build-up, volatile hydrocarbons, and things can go awfully wrong. I'm dealing with a case in America at the moment where 13 LED ground recess luminaires in a row, put a retrofit LED lamp in, and one has exploded. Apparently it's my fault. I'm not quite sure how it's my fault, because it wasn't rated for the lamp, but we'll work through it. And what we understand is that heat and moisture build up, then moisture got onto the LED lamp, we had a chemical reaction, created an explosive atmosphere, bang! It's not a problem until the glass comes flying at you at 60 miles an hour, which is pretty dangerous. So you have to be a little bit careful. When you do it right, a good LED fitting is worth its weight in gold. It will save you huge amounts of energy. It can give you great color temperature choice, even tunable color temperature, great dimming opportunities. Yeah, you don't have an energy problem here, but we do. Okay, so it gives us a great opportunity to reduce our electricity bills and to save carbon as well. It's a great technology. I do raise one question though, as to whether they really will save the world. Because as soon as you offer someone a light source that's cheaper, lasts longer, uses less energy, they put twice as many of them in. You end up back where you started. If you're worried about light, you shouldn't have left them on. If you're worried about energy, you should have installed controls. And this is at 8 o'clock at night in the centre of London. Why are they on? Because the cleaner's got to see. The cleaner's got to wipe the desks. The cleaner doesn't care where the light switch is because the cleaner simply doesn't pay the bill. Actually, in most of Europe and America, the best way to save energy would be to install lighting controls and simply switch the lights on. So there is a gap between what you're told as customers, what I know, and indeed what my suppliers are telling me. There's a gap between what you believe can be done, what we can actually do, and what we will actually do going forwards. But enjoy LED, because organic LED is already coming along, and that will change things in about 5 years' time. And then you probably won't need twinkling tungsten halogen, you'll buy ceiling tiles that light up, or windows that are clear through the day, and then you put electronic current through them at night, and they light up as light switches. Or what about wallpaper, where the pattern lights up? Organic LED, if you don't know, it can be printed. It's a bit like inkjet printing. So you can print it into shapes, or you can print it onto plastic and then cut a shape out. The shape will light up, and the leftover bit will light up beautifully as well. Word of warning though, they're about £6,000 for a 5 centimetre by 5 centimetre sheet at the moment. So if you want to use them, it's going to cost you a lot of money. I do know of a German yacht manufacturer who is installing them on multi-million-pound yachts, but when you pay about £1 million a metre for a yacht, you expect £6,000 for aluminum. No.
Einhverjum spurningar?
I think, did you say questions? Questions in English, I'm afraid, or translate.
Hann fór svona nokkuð vel yfir þetta og það náttúrulega mörg atriði sem fólk þekkir en það alltaf eitthvað sem poppar upp.
I have a question. Manufacturers have been, like you talking about, all those what we have to take care of when we buy LED. And but is there any standards from the manufacturers that they're using together that they produce of the LEDs should fulfill some standards?
Yeah.
Or specifications.
So the question is really, are there legal legislation and standards coming along that will help you specify good quality LEDs? Yeah, I work on some of the standards committees. And the problem we have is that when we invent a technology, it normally takes a couple of years for people to agree how it should be or for us to understand how it will be before we can write standards. So there are some publicly available specifications, PAS documents in Europe that you can freely download at the moment. There are agreements in the industry that say what lifetime should mean, how you should measure it, how you should write it down. The reason they're publicly available specifications at the moment is because legally we haven't agreed to publish them as a standard. But that's happening as we speak. So in the next year or so they will come out as European standards, hopefully also American ISO standards with exactly the same language. At that point you'll have to pay for them, so I should download them now. If you want, I'll give you my card and I can tell you which ones to look at. A shorter term solution might be, I'm not sure of what happens in Iceland, but in the UK we have a lighting industry association. So where the professional bodies and the manufacturing bodies and the standard bodies all get together and publish one document on LEDs that say, as a specifier and a user, these are the things you should know about and the questions you should ask. You can Google it. It's called the LED Specification Guide. It's available from Google. Again, I can send you the link. It's free to download, and then you can put it in front of the sales guy who turns up and goes, I want to know about this. And if you can't answer the question, chances are you're not getting them good quality LED. That same document is now being published in Europe as well. And it basically says the same thing as the available standards, but it's there to help people. Does that answer your question?
Yeah.
But what about the standard they're using today with L70 or F/F10?
L70 and L79 and L80 are American standards. They are in force in America, but we don't like them because they're very Americanized. They don't suit Europe very well. Having said that, in the Middle East markets, places in Australia and Asia, we sell to those standards. There are some issues with them. Remember I talked about life. The standard that tests for life in the States tests at the moment for 6,000 hours. Mm-hmm. And we have a couple of cases where at 6,000 hours, one LED manufacturer's lifetime curve seems to predict it will fail at 20,000 hours, and yet it's gone on to last more than that. So the standard says 6,000 hours. We think you need to test for 12 to 15,000 hours to get a good statistical prediction. Americans don't want to change. Europe is saying, actually, if you've already got them on test, why don't you just carry on testing them, and we'll see how it goes. The other one is the LM80 standard, which essentially means as a manufacturer, if you ask me to quote my design to LM80, I have to turn up, tell you how I design it, how I make it, which materials, how I assemble it. Well, I'm not going to do that, because that's just opening my books to Chinese manufacturers to copy my designs. So you will find the big manufacturers will not actually design or will not specify LM80 because it's just commercial suicide to do so. So they're there, but we're not keen on them. The European publicly available standards will take some of the best bits, pull them together into a format that you should know, and we all agree as an industry it's worthwhile having. Life will be one of them, the F factor, the L factor, all those sort of things, L70, F10, that will all be explained in those.
I want.
Yeah.
Usually when you're trying to help, ask people to try LED, they usually say, it's too bright. They want the old lighting.
Yeah, and that, do you know, in 25 years in lighting, I've always had that complaint, even before LEDs. You go into an office and you take out the old lighting, you put the new lighting in, guaranteed you'll get a complaint from about 50% of the room who say, it's too bright. All light sources diminish with time, even these things. And so you replace them with the equivalent output, suddenly it's brighter. Now, if you then take something like LEDs, and these are probably a good example, you don't really want to look into the center of that, it's too intense. Well, LEDs, to get the same output, would probably be, in the mid-range product, 3 LEDs to get the same light output. So you've got 3 intense sources you look into, it appears much brighter. Plus, your very directional light sources always appear very bright. If you're using a softer, something like replacing a fluorescent, we would use a different LED light source, bigger light source, much softer. But in very directional products, you're always going to get that complaint. Now, the problem for you is, what are you buying? Because if you take one of these at 50 watts, and someone says, I'm selling you an LED 50 watt replacement, and it only runs at 25 watts, and you go, right, so I've saved 50% of the energy. Yeah, what you want to be buying is the same lumen output, the same brightness, the same intensity. And people very rarely sell them that way. In Europe now, we have to. We're not allowed to specify it's a 28 watt downlight. We have to specify it's a 1000 or 2000 lumen downlight, so that people get used to, I'm buying units of light, not buying electrical units. It's a very difficult one.
So you can't just say, I'll half the watts.
No.
No, you can't do that.
No, because what you want is the amount of light. We try to do this. So imagine a hotel corridor, no daylight coming in, and you want to provide 100 lux on the floor. 100 lux. I never understand quite why you need 100 lux, because what are you going to do? Fall off the floor? And even if you fall over it, it's probably not going to hurt. You need about 100 lux to detect if the cleaner's left a cable or something and there's a trip hazard. 100 lux is not actually really required. You can get away with 20 lux. So you do that with twinkling tungsten halogen light sources. They last 1,000 hours. You guys are always in jobs because you go around and replace the lamps every couple of weeks. Sales guy comes in and says, I can do that, half the wattage, and it will last 50,000 hours. And the hotelier goes, yeah, please, that would be great. I don't have to pay the electrician. £20 a lamp instead of 38 cents a lamp. Yeah, okay, I'll go with that because it's going to last 50 times as long. Plugs them in, turns them on and goes, a bit dark in here, isn't it? That's because he's bought wattage and not light. What he should have done is go, that's about 1,000 lumens, and it gives me 100 lux here. So what you should sell me, please, Mr. Sales Guy, is a light source that uses less power and gives me 100 lux on the floor. And you just run it through a quick calculation, and it would take me seconds to do, and go, yeah, you need 1,000 lumens. Now, the other thing in spotlights is you can buy these in anything from sort of like a 3-degree beam up to a 48-degree beam. What you get in LEDs? Probably not the same. If you're buying, replacing one of these, this is probably about 48-degree beam. It's quite intense here, but it's quite soft off here. If you buy the same LED product, it'll probably cut off really sharply here, which means all the light's in the center here, so when you look at it, it's going to look brighter, it's going to look really intense. So I would say, if you're buying LED replacements, and I don't know whether you can do it here, get your supplier to have a couple of spotlights on the desk that you can pick up and play around, stick the lamp in, shine it on a wall or something, see what it looks like, see whether you're getting that color fringing, see whether you're getting a really tight beam, see whether it's replacing really what you want, and look at the lumen output. If it's 1,000 lumen tungsten halogen, it should be 1,000 lumen LED. And then you will save some energy, perhaps not what the sales guy said, but
Tell me about OLED. I've been listening to guys like you and some others for 15 years telling me that OLED is coming.
Yeah, okay, so there are two sorts of OLED. OLED is very difficult to make by most manufacturers. So essentially OLED is a series of very thin layers that generate different light, normally red, green, blue, but you can add amber and other colors in as well. And the more layers you have, the better the white. That's one technology. The problem with it is you have to cook it in a vacuum. You have to put it through a big oven, keep the temperature very stable across its width. You have to take all the air out. It becomes a very expensive process. And now if you want a panel that's twice the width, your oven costs go up by a factor of 4. You want it 3 times the width, oven costs go up by a factor of 9. So it becomes very, very expensive to make very wide panels and very long panels. It's a great technology, but the red, green, and blue aspects of the light last different lengths of time. So you'll find that the green, I think it's the green, has a very poor lifetime compared to the red. The blue is very difficult to get the same intensity of light out compared to the red. So you've got to balance all these things. If you want color changing organic LED, so then you can tune it. You can say, I want it blue, or I want it white, or I want it warm white, or I want it yellow, and you can change it just by powering of different layers. So that seems to be the way most of the market's gone. There is another technology around, which is the printing technique, which you can just do in open atmosphere. You effectively spray a coating onto the surface of plastic or glass. If you want to do double the width, it's double the cost. If you want to do triple the width, it's triple the cost. If you want to do a piece 48 kilometers long, you just need to have a plastic that's 48 kilometers long, and you keep printing. As long as you don't run out of material, you can do it. That's a much better solution. Environmentally, it's better, but you only get white light. You effectively get the light color that you print. So if you want 4,000 Kelvin, you have to print 4,000 Kelvin. If you want 3,000, you have to print 3,000. On the back of it, you put an electronic power distribution. There's a guy in here from Framleiðsla Ljóstvista who probably knows it in much more detail than me. And essentially, you pass power through the organic material, and it gives out photons, it gives out light. Each layer gives out different color. Add those colors together, you get white. Or it gives out one color of white, and you just see it. So the difference is in nanometers of thickness. Print it, you can put it onto plastic materials and bend it. Material that gives out the light is owned by one company. It's very expensive. It uses some fairly rare materials. It's also used very thin. You know, you can imagine 2 football pitch sizes of organic material. You end up with less than a kilogram of unrecyclable waste, and that's this organic material. It still diminishes with time. It's like any other light source. The longer you run it, the less light you get. We're not sure how the color stability is, but it's not bad. It's not yet that efficient. We predict in a couple of years it'll be up to around 60 lumens per watt. Still, that's not actually that good, and the cost will come down. The more you make, the more the cost comes down. Philips at the moment are pushing it very hard. They'll turn up with some panels that you can plug in and you can buy. I'm not sure what the costs are. They look great. I haven't got a product for them yet because I don't have customers that are willing to pay thousands of pounds for repair. But it's still on the way. It's then going to be how you apply it. Because would you really want wallpaper that lights up? I'm not sure. Would you want ceiling tiles that light up? I mean, we have a trend in Europe at the moment to get rid of ceilings like this and to have open surfaces. And then you go, so where's my luminaire now going to go? It's not going to be an acoustic tile replacement. It's not going to be a downlight anymore. It's going to have to be something suspended. Actually, with suspended luminaires, the trend with LEDs is to move to plastic panel optics. So organic LED, which is a plastic panel, essentially could be quite an interesting solution. I think we're still 5 years off an affordable, reliable product that I could use.
I was once talking to a salesman, and he showed me a remote control to a light bulb, LED. What was that?
That's standard LED.
Yeah, we just pushing buttons for.
Yeah, you can buy it now from Philips. It's called Hue, H-U-E. You can buy it from oh, you haven't got an Apple store. Next time you go to the US, yeah, have you got an Apple?
They're selling it here.
Yeah.
In the Apple Store from Philips.
So if you've got an iPhone, the iPhone app, I'm not sure if it's available on Android as well. You buy the app, it uses Wi-Fi essentially. You have to buy a Wi-Fi hub that goes with the lamp. Okay, of course you would. It would be nice if it worked off your ordinary Wi-Fi hub, but it's not going to. And then you can just color control. Essentially all you're doing has a range of colours of LED, normally red, green, and blue, sometimes amber as well. And the intensity of each one mixes to give you whatever colour you like. It's not actually fantastically clever technology. Philips have just grabbed it and marked it very, very well. I haven't got my sample yet.
But it's funny that you can have a remote control and you can just go tell the light to be what you want it to be.
That actually is not that clever. We were doing that years ago. The ability to walk in with a remote control and control something on a closed protocol. You know, I used to be able to do it with infrared remote control. To dim my luminaires, you point a remote at it and it dims. It's the same sort of idea. What gets clever is things like, I walk into my office with my iPad, and my office knows that my iPad is in the room. So it knows what lighting I like, and it changes to my mood. It changes to my mood through the day. Yeah, because it knows I like cold coloured light in the morning, and to dim down a little bit after lunch and go to sleep, and then to warm up in the afternoon to keep you know. So I can do that. And then the technology goes, but okay, you and me are in the room, so there's a bit of conflict because you like your lighting. So there's two iPads in the room now. It goes, so what I'll do is I'll go to an ambient somewhere between the two that won't upset either of them. When your iPad walks out of the room, the lights go off. And the next room you're in goes, oh, Ian's walked in with his iPad, so now I need to change the lighting. We've actually had systems where as you walk around the space, the lighting follows you, changes with you.
But that means you have to carry your iPad around.
Or your iPhone or whatever. Yeah. And then you get problem. What happens if your battery fails? Because you need to leave it on Bluetooth or Wi-Fi all day, every day. But you can imagine we're also trialing, unofficially, facial recognition technology. So this little camera that's filming me at the moment, correct to the right piece of software, can actually tell you that it's me. It can recognize me anywhere in the world. You know, Big Brother is really watching. It doesn't print a picture of me, but it knows it's me that's in the room. And it knows where I am in the room because the camera knows its point of view. So now I can say, Ian's in this corner. I can change the lighting to Ian's requirements here. So if I'm 70 years old and I need a lot more light, the camera could say, put up the lighting level on Ian's desk because he's now there. And when my colleague Lou Beddock's comes in and he's only 35 years old, he goes, Lou doesn't need so much light, so I'll dim it. Now there are real privacy issues because at any one time my employer knows exactly where I am. I'm not sure I'm happy about that.
Well, your employer will be.
My employer will be, and chances are he's monitoring my phone so he knows exactly where I am anyway. But if he's not, the National Security Agency in America's already done that. Yeah, the technology is awesome. We've also seen people playing with the idea of, instead of little downlights like this, you go for individual LEDs and you insert them into ceiling tiles and you control every single one. And now you go, the ultimate downlight solution is that as you walk around the space, the pool of light follows you. And as you walk up to have a conversation with someone, their pool of light is also following them. And when you get close enough together that you want to talk face to face without looking really harshly lit, some LEDs around the side start to light up and push light onto the face so that you look more friendly. And you can even set it now so that, I'm in a bad mood, so my light will follow me around. It will be quite red. So people could see me coming and go, avoid him, he's in a bad mood. These things, I'm not sure when they'll ever make it into the marketplace, but Philips are starting to play with the hue idea. You can control the lighting for your mood and for your ambience. It's a great idea. But when everybody's got the same system, you walk into someone else's lounge and your app goes, ooh, you can control the lighting. It's going to be a bit annoying. Someone walking down the street going, they've got the hue lamp. Watch them. Because you can hack into any system. Any more questions? Well, I'll say two things. One, thank you very much for your attention and the questions. It's been great. I'm around because I understand there's free coffee and all sorts here today. So I'm going to be around for the rest of the day, certainly for the next couple of hours when you guys are here. If you want to ask any questions that you weren't comfortable asking in front of the audience, please come and find me and I'll be more than happy to answer. Thank you very much.
Við erum með annan fyrirlestur í